This podcast is sponsored by Lightstep. Lightstep delivers confidence at scale for those who develop, operate, and rely upon today's powerful software applications. Answer questions and diagnose 100% of anomalies, spanning mobile, monoliths, and microservices across every service in real time. Visit lightstep.com.
Hello and welcome to the InfoQ podcast. The InfoQ podcast is a weekly conversation with software leaders shaping our industry today. My name is Wes Rice. In addition to hosting the InfoQ podcast, I chair the QCon software conferences in San Francisco, London, and New York. QCon San Francisco is coming up November 5th through 7th. We have an incredible lineup of over 140 speakers, including Brian Cantrell, Charity Majors, Nicole Forsgren, Jez Humble, Alex Buckley, and just newly announced keynote on AI from Grady Booch. So I hope you can join us for 3 days of deep dives on everything from consensus protocols, Rust networking, WebAssembly to Kubernetes, DevOps, all the way through culture and organizational change. It's an intense 3 days. Hope to see you there. On today's podcast, we're talking to another influential thought leader who's shaped my own personal software career through his writings and contributions. In his writings and posts, I've learned things like UML, XP, enterprise application architecture, and refactorings. If you haven't already guessed, I'm talking to Martin Fowler. Martin is the chief scientist today at ThoughtWorks and has been since 2000. His books include UML Distilled, Planning Extreme Programming, Patterns of Enterprise Application Architecture, and of course the 1999 refactoring book that he is in the process of re-releasing, which helped re-popularize the word refactoring in software. So if you've ever said, I need to refactor this part of the code base, or clicked on an automated refactoring in something like IntelliJ, you're basically standing on the work that he's done, Kent Beck's done, Ward Cunningham's done, and many, many others. So today's podcast, we're talking about the new book, Refactoring, some of the changes that you can expect. We'll be talking a bit about microservices and evolutionary architecture, and Martin's thoughts on code smells, unit testing, and UML today. Martin, thank you so much for taking the time to join us on the podcast.
Well, thank you for having me.
So as we were talking before this, you said for the last 2 years, you've been focused on this book. Tell us about this journey over the last couple of years.
Well, yes, the revision to the refactoring book. It was something I increasingly felt I needed to do because the book is kind of showing its age in many ways. Most obviously, the Java code examples. I mean, we're talking about Java util vector is in there. Many people are not old enough to remember using that. But also a sense as well of, when you're doing a book that's so totally focused on Java, it tends to have a very class-centered, aggressively object-oriented view of the world, and refactoring is much more general. So I wanted to try to address those issues and see if I could give the book legs for another 20 years or so and ensure that refactoring was still a topic that programmers saw as a relevant one, because I think refactoring is a really core skill to be a good programmer, and it's important to have a book that explores it properly. So that was my target, and it ended up being pretty much a complete rewrite. I mean, there are some sections I was able to copy over, but most of it is completely rewritten.
So speaking of aggressively object-oriented, the first thing that should jump out at anyone who's familiar with the original version of the book is the new version uses JavaScript for the examples. I'm kind of curious why. I mean, is it the ubiquity of the language? Surely there's a few languages out there that may be a little bit easier to demonstrate refactorings.
Mainly because when you're writing a book about programming, the language you use has to be one that the readers can understand. And that immediately cut down the list of potential languages I could use. And oddly enough, Java was still highly ranked on the list because it's still a widely read and understood language. But I went with JavaScript, maybe because it's a touch more, but primarily because although it does have a quite reasonable object model, at least with the ES6 stuff, it also allows you to operate without object, sense of how you want to refactor both without objects, but also towards objects. Because although these days a lot of people say, oh, do you need objects as much? I'm still a big fan of objects. But I'm also someone who feels you want to be able to refactor towards them and sometimes away from them, depending on what you need to do with the code. And JavaScript gives you the ability to express some of those refactorings a bit more. Of course, I hate the language, but
it's always a love-hate relationship.
Yeah, I can imagine there's some love there somewhere, but for me, it's mostly a hate relationship. Well, I always joked with the first edition of the book that how depressing it was to go from Smalltalk to Java, But at least I thought there's no lower I can sink.
Careful what you ask for, right?
Exactly. God knows what another revision of the book would be done,
But it's a nice point to point out that when it was initially written with Java, a very object-oriented language, and now JavaScript, a kind of prototypical-based language, which with the S6 you can get to objects, but still, it's very much a different style of writing, yet the refactorings are absolutely just as relevant as it was with OO programming in Java.
Yeah, I mean, the core idea is still very much the same. It's the idea of trying to identify these small steps. The code is never broken. And you're going through this sequence of small things that allows you to make a big change. And in many of the small things are relatively the same. I mean, there's still extract function. I mean, okay, it's extract function rather than extract method, but it's basically the same thing. That's a core technique that you use. It's moving functions around. It's moving bits of data around. There are some differences. For instance, I have a refactoring to combine functions into a class, which, of course, you don't need to do in a world where you can't write functions without classes. I've also put more emphasis on split phase, which is the idea of dividing your complicated bit of computation into two distinct phases with a data structure between them. That's an interesting one because that's a refactoring I'd never even thought about until I was chatting with Kent Beck. And when he mentioned it, I suddenly realized, oh, that's a refactoring I do all the time, but I'd never noticed it. It's kind of something sitting in plain sight that you've just never seen. And that's a sign of how I'm envious of Kent being able to spot that kind of stuff. I mean, he's been such an influence on me over the years. I've taken so much stuff from him, and he's still able to just sort of toss these things out and say, oh, yeah, I hadn't noticed that, but that's really important, isn't it? And it's made a big influence upon my thinking.
So one of the things I'm curious about is this book was 1999, and now you're writing it 2018. What's been the process? What's been the change, the evolution? And you actually talk about this a little bit in the new book, but what's the change in how you write books today? Or why write a book today in the first place?
Well, that's a very good question. Why write a book today? I mean, the world has changed a great deal in terms of publishing because of the web. And the impact has really hit right across the whole publishing. And I mean, you see it in terms of newspapers, TV stations, everyone's been hit by what it means to have the web. And we're still figuring it out. It's still hard to absorb the shift. It's changed so many of the equations. For me, I mean, for much of what I've done in the last 20 years is focused on my website, martinfowler.com, and put a lot of attention into that. But I still feel there's a need for a book-like work where you really take a topic and you absorb it to a large degree. And that's what was needed with the refactoring effort. I really needed to spend a lot of time covering a lot of ground in a much more cohesive way than you can do with just writing articles on the web. But at the same time, I wanted to link it in with what I do on the web. Part of the setup for redoing the refactoring book was to write a series of essays about refactoring, which I did in sort of 2015 time. And they're on my website. They're currently linked off the homepage. And these are essays like refactoring to an adaptive model, refactoring module dependencies, refactoring calls to external services. All of these were sort of broader, sort of not individual refactorings, but broad episodes that string together refactorings. And in writing those, that helped reinforce for me the need to put a lot of attention again to those individual refactorings. But also, I want a book that's able to evolve with that. Because as you write essays like that, you say, well, actually, maybe we need to tweak some of these refactorings or add new ones in, and I want to be able to do that on an ongoing way. So I had this vision of the web edition of the book, and the web edition actually being the canonical edition. So if you buy the paper book or you buy a Kindle book, what's particularly important to you is you get access to that web edition, which Addison, Wesley, Pearson, have that on their servers, and you get access to it, and I'm able to add material to that over time. Now, I kind of had a vision like that back in 2000, and what stopped me partly was there's so much other stuff to do. And I'm worried that, of course, I may not do as much with refactoring in the future simply because other stuff comes up. But we'll see. But at least I feel I have a bit of a mechanism and a bit of an encouragement to do that. And some of the refactorings that I've done and finished actually don't make it into the print edition. I think there's 4 that we held back and they're only going in the web edition, partly because I didn't want the print edition to be too bulky, and partly because I want people to get used to the idea that the web edition is the canonical book. And that's the one that hopefully I'll add more to later on, because I've got a huge list of refactoring topics that I really wanted to hit, but I just didn't have time to hit to get the print edition out in a reasonable amount of time.
So let's talk about some of the new refactorings. You talked about split phase earlier. What are some of the new refactorings that are in the book? Maybe what are some of the things that are online and some of the things that are in the book?
So yeah, I'm looking at a list of some of the new refactorings now. It's an interesting mix. So there's some that are definitely, you can see because I've moved away from being as class-centric. So combined functions into class I mentioned. I've also got one called combined functions into transform, which has, again, this notion of, as with the split phase, where you want to fuse the functions together because they're making a data transformation. So you've got a pattern of programming where you're transforming data structures into other data structures in a kind of more pipeline-ish view of the world. And that doesn't necessarily require the class structures. So that's there. I've also got a bunch of refactorings that I considered kind of too trivial to put in the book that are about just moving bits of code around. So sliding statements up and down a method, or moving function statements into a function or out of a function. Remove dead code. Now, that's a really important refactoring, and I didn't even mention it in the book. Those were all things I kind of considered too trivial to talk about, but I've since felt, yeah, I need to put those in.
Yeah, but the refactorings in general are things that you just learn. You almost feel like they're common sense, but they're not codified into a place to say, look, these are the common sense things that you learn by just doing, but here they are. So that's what was so powerful about refactoring.
Yeah, and it's interesting that I felt the need to switch there and to say, okay, I've got to go into this slightly different set of things to talk about. But I really did feel that I needed those. It's just interesting to look at those and get them in. There was a couple around inheritance that I had to really reorganize to do with switching in and out of using subclassing, for instance. And also, a very important one is replacing loops with collection pipelines.
Sure, absolutely.
It's ironic because it was something I had to kind of really ignore when switching from Smalltalk to Java, because in Smalltalk, they made it very easy for you to write collection pipelines, and I used them a lot. And then in Java, I had to kind of give that up. I mean, you can do it with Java and inner classes, but it's so ugly, you just don't bother. And then, of course, now we've seen those affordances come back. Java has got them with lambdas. JavaScript always had them to some degree, but has got the appropriate operators, the filter and the reduce and the like. And now it's much more a common piece of programming than it was in 2000.
It's that move back to declarative from imperative programming.
And that's a really good thing, because, I find it so much nicer to use collection pipelines rather than loops to express that kind of computation. And of course, I got very used to it because I did so much of my programming in the last 20 years has been in Ruby. And Ruby makes it really easy to do that, which is, of course, one of the reasons why I liked the language so much and used it so much.
One of the things that I really liked about refactoring is influenced me in a lot of different ways, and I saw it kind of change in this one, is you reveal a lot of your thought process as you're kind of talking about refactoring, how you think about this, things that are coming into play, and you kind of like talk about peripheral things such as making sure unit tests are set up before you ever do anything. Well, it's probably not peripheral, but in before you talk about like you start with class diagrams and kind of draw out what was going to happen, or sequence diagrams in the book, where this time you talked about like at different points you're checking in code, for example. I always found it very revealing when you kind of like, it was almost like pairing with you as you were going through doing this book. It seemed like a very intentional design decision.
Yeah, I mean, that's definitely part of my view of the book, is to try and be that if you were pairing with me, what would I be saying? What would I be thinking? And trying to really get all those bits. And that's actually an interesting thing you mentioned. One of the changes is the role of version control. Because, of course, 20 years ago, we didn't have distributed version control. So there was much more of a sense of, oh, it's a big deal to check things in. And also, version control was thought of differently. I mean, the idea of regular check-ins, that you might do several a day was ridiculous to people. And now, I mean, you have your local copy. I'm always checking into my local version control. And you've got a very different relationship and a different general comprehension of how version control works now. And that's quite an interesting difference over the last 20 years.
And you were very specific in it because you're like, you complete a single refactoring all the way through so that you have that check-in and then squash all of them together before you actually push upstream. So that way you had this whole collected. It wasn't specifically about refactoring, but it was how to apply refactoring to the idea of version control. And inversely, where before we were whiteboarding or drawing out UML, that was kind of removed. So it's interesting to see kind of thought process 99 versus thought process 2018 and kind of how things maybe changed. You're scowling.
Yeah, although having said that, I didn't really do much pre-whiteboarding. I don't recall mentioning it particularly in the first edition of the book. And the first edition does have some refactorings illustrated with UML diagrams, and I don't do that now. And that's an interesting thing, why I decided to drop that.
That's the root of the question. So why did you decide to drop UML?
Well, I mean, I've noticed certainly in my circles, people aren't using it that much and aren't really that familiar with using graphical notations. They seem to have dropped away a good deal. And I asked my little review board about it and said, is it better to illustrate the sketches, which is just really a mental, oh, this is what this refactoring does, using code rather than UML? And they basically all said, I think code is better. So I went to use code instead. It's because of one less dependency for the reader. They don't have to be familiar with graphical notation. I did come up with these little pictures to try and illustrate a refactoring, and I'm not sure how well they're going to work in the whole, but it'd be interesting to see if people find them a good aide-memoire. But really, the main one is the code example. If you can kind of look at the code and say, yeah, that's what this refactoring does. And of course, plenty of the refactorings in the first edition used code to do it, maybe about half of them, maybe more than that. But this time I decided they're all going to have before and after code snippets to try and illustrate the refactoring.
So that actually begged the next question is, what is the role of graphical notation today? Is the role changed? Is there some new notation that we should be paying attention to? Or is it code?
That's a good question. The UML did a good job of unifying the graphical pictures that we had at the time, because we had this complete cacophony, of course, in the sort of late 80s, early 90s before it came along. But it also kind of, I'm not sure that we really explored what would be the most useful ones to use. And at the moment, we've kind of slipped away a bit from that. In some ways, in a good sense, because I think it is a good idea to always have that. It is a good idea to put your emphasis on making code comprehensible. And that has really got to be the highest priority. And then trying to draw what you can out of the code as much as you can as well. I think there still is a role for the graphical notations. I think they're still valuable. I certainly find it still useful to sketch a class diagram or sketch a sequence diagram at times. But I do find myself perhaps putting a lot less emphasis on it than I might have done 20 years ago.
I mentioned whiteboard before. That's how I tend to use it, is with a whiteboard describing different things as opposed to modeling it.
And that's certainly true. The whiteboard is still a great tool. But of course, I'm also a fan of using cards, and getting motion into thinking as well can be very helpful.
As you're going through your different examples, you're kind of illustrating your thought process. We talked about Git. We talked about class diagrams before, or sequence diagrams, and how you're kind of modeling. I see the refactorings point. At what point do you start to shift from, oh, I need to use a design pattern such as a strategy pattern, in particular with that switch statement, versus refactoring, extracting another method, extracting a method? Where do you start to make the switch and go, actually, I need to use the observer here. I need to start to make that switch.
I don't think there's a hard line about it. There was a metaphor that Ralph Johnson used that I always liked, said that a lot of the early refactorings are like cleaning the dirt off the glass of a window. You just need them to be able to see where the hell you are. And then you can start looking at the broader ones. So that's why a lot of the first refactorings you do are just extracting stuff into functions so that you can begin to see what the territory looks like and beginning to sort of lay out the beginning of, oh, if would a class be useful here? Or this set of classes, is it really right? Do I need to move things around a bit? And then you begin to see some of the broader moves that you can make that move you towards the bigger patterns. I mean, this is stuff that Josh Kerievsky covered quite nicely in the Refactoring to Patterns book that sort of lent on from this. And it's also something I might explore more with essays later on. I mean, because that kind of territory starts getting quite interesting. I mean, that was particularly true with, say, the Refactoring to Adaptive Models essay, where I talked about, this very powerful pattern of the adaptive model and how you might refactor towards using something like that.
It's interesting. It's almost decomposing the monolith with refactoring, right?
No, I wouldn't go that far.
Decomposing the monolith of a function of a class,
right.
Breaking things down into very small is what I mean.
Well, it's certainly the case of breaking large, complicated things down into smaller things, because then it makes it easier to move them around. and to reorganize them. And that's certainly been a large part of how I think about refactoring. I'm always trying to take the big thing and break it down into smaller chunks so that I can more easily manipulate them.
I want to shift gears just a bit and talk a bit about microservices. I mentioned before we started recording that there's a post that you made, microservice prerequisites, around 2014, that was like, you must be this tall for microservices. And in that post, you talked about rapid provisioning and basic monitoring and kind of rapid application development. It's 2018. How tall do you need to be for microservices today? Is the bar still the same? Is it higher? Is it lower?
I'm actually not quite sure I can answer that question because I've been focused so much on the refactoring stuff. I haven't really been looking at all at what's been happening in this space. And I know there's a lot of interesting things been happening, things like the rise of Kubernetes, the fact that we're seeing also a general shift towards cloud platforms, and cloud platforms are providing a lot of affordances for a more microservice-based approach. I mean, that stuff we've been talking about it a good bit, for instance, in our radar sessions at ThoughtWorks. But what I haven't done is spent the time personally to really look at this and see what difference it makes. I mean, the fundamentals are still in place. I mean, you still need to be tall enough to be able to easily deploy into production. You don't want complicated deployment paths. You've still got to have a lot of the elements that are part of that microservices prerequisites. The question is, to what extent are the tools making it easier to get up there? So you've got to be this tool. Are the tools giving you some boxes to stand on to enable you to get there? And what I don't have a sense, because I haven't really looked at it enough and talked to my colleagues enough, is to what extent the tools are actually delivering on that. Some things, however, they're not going to deliver on. I mean, yes, they can do things like give you built-in abilities to do circuit breakers to talk to other services. And that's cool. But there's still stuff that's really fundamental to your design. When you're not in a microservices world, when you're in a monolith, you make a call, you're not expecting that call to fail, because in process calls, I mean, if they're going to fail, you're down anyway, right? So you don't worry about it. When you make a call to a remote service, it could always fail. And one of the principles of thinking in a microservices way is you acknowledge that. You don't try to hide it like typical RPC thinking tended to. You say, okay, what do I do if this call fails? And you still have to go through that thinking, even with whatever tools we provide, because the response to a failed call is something you've got to take into account in your design. There is no always answer to this. So that complexity does not go away. And that's the factor. The tools can make some complexities go away, but there are fundamentals about distributed programming that are not going to go away, and you still have to deal with those in the microservices world.
So when we talk about refactoring, we talk about code refactoring. Is there an idea or concept that refactorings that could be applied at architectural levels?
Yeah, and in fact, interestingly, although I've had these blinders on and not looking outside refactoring, some of my colleagues have. And two of the things I've published on martinfowler.com recently have been from my colleagues looking at exactly this. How do you break a monolith down into microservices, coming from the experiences that they've had with some of our clients? The first one by Zermatt really looks at sort of the broad principles of how you do this. And then the second one that Praful did looks at a really solid example. And what was interesting was actually sitting down with him going through this, because the original version of it he showed me, the idea was good, but it didn't really go into the solid details. And to go into the solid details actually required much of the same thinking as I was doing with a refactoring book. Let's get some code examples. Let's come up with a code example. And he actually used a lot of the same tooling that I'd written to help me write the refactoring book. In some ways, it's a fairly wacky thing where I actually have the sequence of refactorings captured in a separate Git repo, which captures the sequence of refactorings. And it's a separate Git repo to what I have the book in, because the Git repo is the capturing of the refactoring sequence. You have to think about how you're working with a repo completely differently, because you're actually doing the thing you should never do, which is edit history all the time as you work on the refactorings and get them straight. And so we had to go through that with the microservice breakout. And of course, it's the same refactoring principles of how do you do things in small steps. So the essence of it, you first actually do the breakout completely within the monolith, separate the tables, separate the code, all within the monolith. And you do that, and then you move to the separate service. And that's, again, this principle of do the smallest possible step and then sequence the steps together in order to make the bigger change. So that's a very good example of refactoring thinking applied to this broader architectural sense. And I thought that came out really well.
That's where I was going with decomposing the monolith. It felt like these sequential steps that you're metabolizing, kind of putting together, that you could take the same thing and apply it to different stages of a microservice evolution. Speaking of that, you recently wrote an introduction to Neil Ford, Rebecca Parsons, and Patrick Kula's book on evolutionary architecture. So evolutionary architecture, is that just microservices by another name?
No, it's a much broader principle, the idea that architecture is something that is a constantly changing thing. And this actually goes back to the very earliest days of extreme programming, because, of course, extreme programming challenged the notion that you have to get your design of your software up front and then execute on it. And instead, the notion that the design should always be changing was seen as very horrifying. And I mean, Rebecca talks about how when she was with clients, she was constantly told that the idea of an evolutionary architecture was irresponsible. But what we've seen over the last 20 years is we're doing it with our clients on a regular basis. And the question is how to capture the knowledge of how we do that and pass that on. And that's what Rebecca and Neil and Pat put their efforts into doing with that book, because evolutionary architecture is really where it's at. Your architecture of your systems is going to be under constant change. And you design your architecture with that change in mind. And you design it in a way that allows you to be able to make that kind of shift, even when you don't really know what kinds of shifts are coming. And I think that's the essence of it. And microservices fit into this because you can evolve towards microservices. You might also evolve away from them. So they're part of the ingredients, as it were. But what's really fundamental is this attitude that says evolutionary architecture is a central part of the fundamental thing that you're going to bring to your mind.
Yeah, always evolving, you're always deploying, you're always changing, it's always evolving. Absolutely.
Yeah.
So I'm curious, how do you see DevOps and teams play with evolutionary architecture? When architecture is continually evolving, teams are continually evolving, how do these two merge together? What's the space between there? Any thoughts in that area?
Well, the key thing to remember is the primacy here of Conway's law, that your architecture and your team structure are going to reflect each other. The architecture fundamentally reflects that team structure. And if you try to work against Conway's law, then you're going to get yourself into a lot of difficulties. So your team structure and your architecture should both evolve, and they should evolve in a compatible way. Often you can do what we call the inverse Conway maneuver, which is to alter your team structure in a way that will cause the architecture to move to follow it. And that's something that we see done and that we encourage people to do. But the most important thing is to remember those two are very much in sync with each other. And so you have to think of them as not separate things, but very, very closely connected things.
There's some gotchas in there, though, right? I mean, maybe you've got core services that you just really don't need to touch all that much, and you're working on a new release, so you sort of starve the care and feeding of that core service so that you could focus on delivery of new features. Or maybe structures around the idea of product and features versus platform teams. I mean, there's just some practicality of aligning your teams around what you want your architecture to be with its implementation, no?
Oh, it's certainly tricky territory, right? Because, I mean, in particular where you say this notion of, I'm a big fan, and we're generally big fans of what we call product-oriented teams. The focus on a business capability, and absolutely not in favor of, for instance, the technology-oriented teams, front-end team, back-end team, database team. Very much focused on, let's get all the front-end database, back-end people together in order to support a business capability over time, with a long-lived team that follows that business capability. But having said that, there are some things that tend to spread across a whole organization that aren't necessarily easily tied to a single business capability. And that's a fundamentally hard question of how do you make that division? When do you make that division? And I say hard as in I haven't got a clear vision of how to pick that out. And to be honest, that's been a regular problem. I remember talking about this back in the 90s. It was clear to me that technology boundaries aren't where you place your team boundaries. But once you manage to get past that and begin to think in terms of capabilities, and then start thinking about what's core and what's more focused on a customer, then we begin to get into much more difficult territory. I do think you should look to err on the side of having things more decentralized, more customer oriented, and have a little too little of your core services that support lots of people. Because I think the trouble you get into by doing that is less trouble than the trouble you get into by putting too much into core services. And the other thing is also one of the core notions, I think, of platform thinking is you want the notion of a platform being a self-service thing for your customer-oriented teams. So you don't be in a position where you're raising tickets against somebody else for them to do something. You really want it to be very much self-service. And we're seeing this, of course, with cloud. I mean, the essence of cloud is, as a product-oriented person, I can spin up servers. I don't have to ask some team to provision the server for me. That's the essence of cloud thinking. And with any core services, we need that same kind of notion, that you really want to set things up so that the customer teams can do everything they need themselves and can call in the necessary capabilities and not have to ask somebody else to do some work for them.
So last 2 years, you've been working on refactoring. What's next?
I'm not allowed to think about that until I get this done.
Well, you're there, right? I just saw it went to the publishers, so the job's done, right?
No, well, there's still a bit more. The web edition has to be finished off. So I'm at the moment working with the web edition to see how that looks. I also have to redo the catalog that lives on refactoring.com to put in all the new refactorings and deal with the changes that have occurred in the book. So those tasks have to be done. So I'm thinking next year I'll be able to start thinking about the future. But at the moment, I'm deliberately not trying to think about that too much because I'll only get excited about something else I can think about. And I daren't get excited about something that's going to distract me from getting this thing done. Because, I mean, starting things is easy. Finishing things is hard.
Last 20%, right?
Yep. And I really have to kind of push to get over that finishing line. It's always the last bit that's the frustrating and slow part of it, the hard part of the process.
So I think the official release date is the end of the year, December 31st, but there's a few channels you can get the book now, right?
Yeah, you can get the book through Rough Cuts now through Informit. And we think it will be available before the end of the year. Since the book's gone out to print, it should appear in Pearson's warehouses a good bit earlier than the end of the year. But of course, the other thing is the web edition. I actually have to get the web edition together. So I have to spend the time to get that done. But yeah, I'm hoping it's going to be earlier than the end of the year. I mean, the end of the year is just Amazon's guess. I think we'll be a good bit before then. But I don't want to promise any dates because it's one of these things where with the web edition, it really looks like it ought to be straightforward. And then you run into complications. Hey, that's the way it goes.
Yep. Just like writing software, right?
Yeah, a lot of it is writing software, actually.
So, Martin, thank you so much for taking the time to chat. And thank you for over the years helping me along my career.
Well, that's what I hope I do, is make it useful to people in helping them be a better programmer.
Thank you so much for joining us on the InfoQ podcast.